in Creation Watch today. It is going to be somebody new. I do try to engage with new people as much as possible. I don't know if I'm just going to do, it's a 2-part series. I might do part 1 now and part 2 at a different point in time. I'm not even sure yet how I'm going to break this down. We'll see how long it takes to get through it. But we're actually going to talk about one of my favorite subjects. There goes my voice. Good gosh. Oh, but I sound kind of sexy now. I sound like Jennifer Tilly there for a second. Oh goodness. Anyway, we're going to talk about one of my favorite subjects, which is something that we call, or used to call, living fossils, or and also a phenomena that is sometimes known as Lazarus taxon. Okay, so this is a new channel that we haven't covered before, and most of his content is science-based, so we may be able to visit this more in the future because, well, let me show you. I got his channel pulled up here. Well, we don't need to doubt right now. Well, you always got to be doubting. All right, there we go. So here's the guy. It's called Creation Unfolding, at Creation Unfolding on YouTube. 1.55K subscribers, so pretty small channel like myself. He makes videos about science, right? He's got videos about evolution and things like that. So, I mean, if you look, there's dinosaur lectures and talking about pycnofibers and Western Interior Seaway, Darwin finches, geology. He talks to people too. He has interviews and things like that. Really high production quality as well. Did dinosaurs have feathers? Things like this. And so he's a creationist. He's a younger creationist, and he's got opinions. So I've started to work on his videos in the past and doing responses to them, but he is really informed and educated. So he does make claims that require a lot of research, and it's always just been since I've discovered his channel. It was just a couple months ago. It's always just been needing too much research for me to be able to do in the short time I have between working on stuff here and doing my real life. So when he finally started releasing stuff that there is other videos that I could respond to that make claims that he makes. But today, especially about the bird evolution, he does a whole huge series on bird evolution. That was the one I was originally wanting to respond to. And it's just so huge. It's just so huge that it's, because there's feathers, and then there's, and you can't, it's hard to respond to one without responding to them all. It's a huge series. I'd have to carve out a lot of time and just dedicate it to that. And I would love to, because there's a lot to go over there. But so far, there's on the Coelacanth section, there's only been these 2 shorter videos, both under 15 minutes, which is excellent for what we do here in the Hive. So, yeah, let's dive right into it. Okay, so, yeah, I'm going to reintroduce here Creation Unfolding on Creation Watch today. Okay, so here's Coelacanth Part 1.
Number and have therefore never experienced substantial opportunity for extensive change in modal morphology because species provide the raw material for change at this level, and these groups have never contained many species. In other words, low numbers of species mean low numbers
we're
of...
way far into it. Hold on. Sorry, I thought that was the beginning.
Is the coelacanth still considered a living fossil?
Yes. In the same way a shark is considered a living fossil. Challenge for the day. Challenge for the Hive. Guys, I want you to, in your brain, every time he says coelacanth, say the word, replace it with the word shark. Okay? Because sharks are just as ancient and have changed just as little as modern coelacanths have from their ancestors. So keep that in mind as we move forward.
Living fossils represent presently existing organisms that are also found virtually unchanged as fossils in the geologic record. Some examples are the ginkgo, the sequoia, horsetails, the lingular brachiopod, nautilus, the horseshoe crab, tuatara lizard, and of course the coelacanth. Recently, however, a number of scientists have sought to remove...
And I want you to take notes of how he avoids major successful clades that are living fossils as well. Beetles. Beetles are living fossils. They're the most numerous animals on the planet, and they're living fossils. There are beetles alive today that look the same way they did in the Carboniferous. You can go to Mason Creek in Illinois and find among the Tully monster. You know what Tully monster, the weirdo, this weird ancient creature that had a one single claw on the end of a snout and a shrimp-like body. Really weird creature. These before time aliens living right alongside modern looking beetles. So, yes, beetles were and are a living fossil. Sharks are and were a living fossil. By the definition of what a living fossil is, that would be an organism that hasn't changed its aesthetic morphology, its physical appearance and structure over a long period of time, and still occupies the same ecological niche. And we will be going deep into that on this topic, so it may run a little bit long, and I'm sorry, but there's a lot to cover.
The term living fossil from the paleontological vernacular by appealing to the philosophical underpinnings of evolution itself. Since all biological systems continually evolve, then all organisms removed from ancient ancestors by millions of years cannot possibly be close living descendants of those organisms, even if the descendants bear some morphological affinities to the ancestors.
And that's a mischaracterization. The reason why we're removing the term living fossil is because that it suggests that this is the same species, not that it has the same morphology and everything, but it's the same species as its ancient ancestor. As far as we know, there are no species alive today that are identical to the species that were alive even just a few million years ago. Even if the changes are subtle and can't be seen by the layperson in the morphology and function and behavior of an organism in our short little span of time, that does not reflect that the similar appearing organisms are the same species. It's like in the future, for instance, once lions and tigers are long extinct, only the experts would ever be able to tell the difference between a lion's and a tiger's skeletons. And we wouldn't know anything about their different morphologies or behaviors, right? We would not. Looking at the skeleton of a lion and skeleton of a tiger next to each other, the only differences that you're going to see is that the tiger is marginally larger, and that the lion has marginally longer legs. That's what you're going to see. But that's not going to inform you. And again, that's within an era, an area of, or an era, a margin era, within a margin of error. Sorry about tripping over my tongue there. Within a margin of error, within the clade, right? Within Panthera, there are tigers with longer legs than lions. There are lions that are bigger than your average tiger, but in general, the populations trend towards those physiological differences that we can detect if we know what to look for, even the experts. But there are things about them that you're not going to be able to infer from just a skeleton, like things like their social structures. Lions live in prides and large groups or families. Tigers are almost exclusively solitary, except for a mother with her babies. You won't be able to interpret that. But if one of them was extinct and we only had the other one, we would still consider a lion in the category of living fossil with it because we had extant tigers if they were extinct. The same situation is here. It's saying that when we call these ancient animals living fossils, we can only apply it so far as family and maybe genus that they belong to. We can't go any further than that with it because we don't know enough about their genetics in order to make that assertion.
In this paper, for example, the authors proceed to apply this reasoning to the coelacanth, perhaps the most iconic of all living fossils. So let's dive.
I would have thought the horseshoe crab was the most iconic of living fossils. Yeah.
Dive in and take a look what all the fuss is about. Today,
he said dive in too. I swear I didn't steal that joke from him. I promise. I didn't realize he said that.
Coelacanth group is made up of just a single genus, Latimeria, which contains 2 known species. Comparing this modern genus to the supposedly 400 million year old Diplossus.
Yeah, and let's do the same thing like I said before. Let's use the word sharks instead of coelacanths, and let's use I don't know. Pick me an ancient species of shark, not megalodon. That's too recent. Give me an ancient one. But anyway, comparing that to a modern mako shark. Let's say down here we have a modern mako shark, and up here we have an ancient species of shark. Right? Let's keep that in mind because this is the same argument. He's just using coelacanth because modern coelacanths are rare and they were more common in ancient times.
Seeds, and it doesn't take long for one to be convinced of their striking similarity and why the term living fossil was aptly applied to the living Latimeria. And of course, one can also see why.
And to the living sharks, right? And to living sharks today. Sharks would be living fossils in the same way. Beetles. You could do beetles too. You could put a modern scarab down here, and then one of the beetles from Mason Creek up here. Same difference.
Why creationists are so interested in this subject. After all, according to standard evolutionary theory, genetic mutations combined with natural selection and genetic drift are constantly at work, changing the genome so that new adaptations and thus new organisms are always evolving. Of course, evolutionists are not without answers, and
yes, always evolving. Well, I should say always evolving. The genetic changes within the population is going to be dependent on the environment and the stability of the environment. So, coelacanth live in a deeper region of the ocean that doesn't experience a lot of change in pressure. They fill a niche where it's not going to be cladistics, Mark. It's going to be today. It's going to be ecological niches that is going to destroy this argument. So this zone of the ocean, while it may shift around quite a bit, is pretty stable in all climates. That's the best part about it, because it's at this point in the water column where it gets climate from above, but it also gets climate from below, from thermal vents, and also these deep down Arctic current rivers. There's like, so in the ocean there are rivers under the water. There are rivers of Arctic cold water that flow under the ocean. So rivers under rivers. The world's largest waterfall is actually underwater. It's off of the coast of Greenland, and it spills off. The Arctic Ocean spills down into the North Atlantic, and this huge cascading waterfall that's like thousands of feet high. It's the biggest waterfall in the world, and it's underwater. Because these Arctic waters flow down, and then they create this zone in between where it's getting climate from above and below, and if there's thermal vents balancing that out, it creates this zone that's completely independent from what the surface climate is is experience. It has its own factors that come into play. So we have this stable middle zone in the ocean that's always existed as long as we've had water on this planet. As long as there's been a water column, this zone has existed. And it's been stable.
Several hypotheses have been put forward to explain this remarkable stasis. Some have proposed the work of stabilizing selection. This mechanism weeds out the traits of a population that are at one extreme or the other, thus leaving selection to favor those traits representative of the overall average.
Let's talk about stabilizing selection here for a second too. So stabilizing selection is like how leopards, for instance, jaguars too, have a it's recessive in, I think it's recessive in jaguars, but it's not in leopards. But anyway, they have the genes to produce melanistic individuals within the population, right? To produce individuals that have black coloration. Now, in certain habitats, this is selective. This can be selected for and stabilized within the population because there's a success rate and benefit in denser tropical habitats to have a darker coat to be able to blend in, especially at night. Whereas more open lands, the dappled rosettes are more prominent and more successful. So you'll see the stabilizing effect, including the melanistic traits in the jungle biome, for instance, but in the savanna biome, those traits become those traits are not passed down. They become excluded from the population because they aren't as successful. And then so the stabilizing effect there would be to not have the black coat. And you can see similar things in like an Arctic environment with a white coat, right? That the groups will be more successful with the white coat. The wolves up in the islands above Canada have a uniformly white dominant coat, where the further south you get, the coats are gray. So there's the stabilizing effect there as well. The presentation of here is that it's not eco-dependent, and I don't agree with that.
A popular example is the average weight of human babies. This average remains constant through time because premature babies, which are small, can struggle to survive, while large babies have problems getting through the birth canal. Traits for these two extremes therefore tend to get removed from the overall human population.
Right, and he's like did kind of a bait and switch there, where we're talking about ecological system, right? There's no perfect middle ground where the other two are just unviable, where the baby's too big and too small and all that. I mean, that is stabilizing effect, but it can be a lot more subtle than this, and it should be considered a lot more subtle than this. That's why I use the pelt coloration instead. I think that's a better example than human babies, because it gives you contrast to say that, yeah, because there's no environment where you're going to say, well, a human baby would be more successful being larger in this environment or smaller in this environment. That's just not a thing. So this is just there's a smaller area of the stabilizing effect than what's demonstrated here. It's less cut and dry, I guess. It's more graded.
Or at least they did just a few hundred years ago before the...
Oh, and when I say graded, let me explain what I mean there. I'm sorry. So it's graded in the fact that in one area it's successful and in another area it's not. There's no area where a giant baby is going to be successful. So it's making it sound like it's just this or nothing.
Advent of modern medicine. This mechanism, however, only works in very stable environments where external pressures are minimized. Yet,
really stable environments. There are a few environments that are stable, especially marine environments that are stable just throughout, as long as we've had oceans. So let's see what he says.
Since the time of Diplocycides, there have supposedly been 5 colossal mass extinction events, with one of...
It's funny when he says they're talking about extinction events and he's showing things that survived the extinction events. The Devonian extinction event, he's got some starfish and stuff. The Great Dying, he's got a, I believe that'd be is that a therapsid of some kind? A bird for the KTG. I guess the trilobite is one that didn't survive. But I saw a bony fish there. Bony fish survived. He's showing the survivors of the extinction events. Is that the goal, though? Because there are traits that we find in organisms to help them maintain through extinction events, and we'll talk about that in a second.
One of them wiping out 95% of all...
Good grief, I've been rambling on and I'm only 3 minutes into the video. You guys need to tell me to just shut up and let the video play. So you talk too much, Bree.
Animal taxa alive at that time. On several occasions, huge volcanic eruptions produced thick and extensive sequences of flood basalts, which covered massive tracts of land.
That's the Great Dying he's talking about there. This is the Siberian traps. Boom, there were, they killed, during the Great Dying, 90% of life on land, and I think like 75% of life in the ocean, but life in the ocean did persevere, and along with life in the ocean was the coelacanth and its stable position in the water column, because they can just move up and down as they need. They live in a colder kind of pocket environment between the midnight zone and the surface. Sharks tend to dominate the niche on the surface, but at this level, this mid-level depth, coelacanth is king.
And even ocean floor with millions of square kilometers of basalt that simultaneously released trillions of tons of sulfur and carbon dioxide, along with many other harmful gases, directly into Earth's oceans. We are also told that the Earth has experienced multiple bolide impacts, with the one occurring at the end of the Cretaceous supposedly killing all of the dinosaurs. There is also the collision of Gondwana and Laurentia during the late Paleozoic.
I love how he's making it sound like the collision between these continents was like they ran into each other like a car crash, and that was a catastrophe. For the most part, I mean, yeah, there probably were there definitely were earthquakes and volcanoes involved with the tectonics here that took place, but this is over periods of hundreds of thousands of years that this took place. The continents are still moving now. I mean, they're not moving at a slower or faster pace, just chugging right along at the same pace. So if the collisions and separations of these continents were catastrophic events, we'd be experiencing it right now. We are currently experiencing the collision of North and South America, for instance, of the North and South American plate. The Pacific plate is pushing up under the North American plate. That's why we have earthquakes and stuff along the west coast of North America and South America, is because those continents, North America up here and South America down here, are folding into each other like this, and the Pacific plate's just pushing right up underneath them. Wild stuff. And if we are not living in how he makes it sound like this would have been some kind of major destructive event, it's kind of strange. It's a strange way to present it.
With the subsequent breakup of Pangaea during the mid to late Mesozoic, not to mention the copious swings in climate, oscillating from one extreme to the other over hundreds of millions of years. So stabilizing selection, that solution, it just isn't going to fly. Low species diversity has also been hypothesized. Stephen Jay Gould, for example, said they, speaking of living fossils, simply represent the few higher taxa of life's history.
I could not find this quote anywhere. I found a quote similar where he was talking about a different evolutionary biology subject, but it wasn't living fossils. I think it was Lazarus taxon.
that have persisted for a long time at consistently low species number and have therefore never experienced substantial opportunity for extensive change in modal morphology because species provide the raw.
Yeah, low species diversity in a stabilized ecological environment preserves basal traits. All fish. It's so bizarre that they act like this group of fish, just this one, preserves these characteristics because of evolutionary biology stability. But all fish do. All fish that are alive now are maintaining. Yes, Dr. Tapioca Weasel misquoting Gould. I'm shocked. But yeah, all fish maintain these basal characteristics. I don't know why that. What's the obsession with just the coelacanth? Is it because that we thought they were extinct for a while and now we know they're alive? Because there's nothing else really special about them. There were these fish and sharks and all sorts of fish that still look the same as same now that they did back then, or similar now that they did back then, about the same amount of homologies as modern coelacanths to ancient coelacanths. Like, again, replace this with a shark, replace this with a beetle, and be like, oh, why do beetles still have beetle parts after all this time? It's the same question. I don't know, why are there still monkeys in reverse? It's like looking back and say, hey, why were there monkeys back then? I don't get it. Why were there coelacanths back then like the ones they are now? Because that's when they came into existence. That's when they evolved. That's when they moved into their niche and stabilized their population, and they've been there ever since, just like sharks and just like beetles, just like horseshoe crabs and all these other clades that have maintained, like dragonflies. I don't understand the objection here. Someone explain it to me.
Material for change at this level, and these groups have never contained many species. In other words, low numbers of species mean low numbers of mutations, which thus means low numbers of useful traits that natural selection can then act upon to build new organisms. There are, however, a number of problems with this hypothesis as well, the most salient of which is the problem of extinction.
I love salient. The most salient of it. I'm gonna add that to my vocabulary. Thank you, Creation Unfolding. I'm gonna have a salient time reviewing this video. So let's continue on with the salience. I have no idea what that word means.
If a genus has low species diversity, then that genus as a taxonomic group is more prone to getting wiped out in an ever-changing and competitive environment.
Why? No, they just have to find. They have to be in a stabilized pocket. Giant tortoises used to be a global phenomena, right? Giant tortoises used to live everywhere, up until really recently, because humans like to eat tortoise, and we've been eating tortoise for a long time. We ate tortoise until there were no more tortoises, no more tortoises on the mainland, but in little pockets where they were stable, they persisted. As Gould said, they persisted in their stabilized environments on islands around the world until modern times, when we discovered these islands and settled them. And some of them were wiped out early on before they were documented by science, and some of them still remain today. But they did persist in isolation. Away from the extinction event that impacted their species.
Given Gould's assessment, how in the world could this little subset of fish spend 400 million years dodging multiple mass extinctions, devastating volcanic eruptions, earth-shattering bolide impacts, and at least 2 ice ages? And
all fish did, hun. All fish survived that. All the fish that we have today survived that. Or their ancestors survived that, so to say. Same with the coelacanth. It survived it. Sharks survived it. It's okay. That's we know that animals survive these extinction events. It's weird that I have to explain it to you, but that's okay. Yeah, I'm being a little condescending and cheeky, but this is a silly argument. Because how this species survived an extinction event event? No way. When we know that species survive extinction events. We have dragonflies. They survived more extinction events than the coelacanth did. And they're still kicking. Dragonflies are still rocking it.
If that isn't enough, this little coterie of rather harmless fish...
No such thing as a fish, right. Well, so yeah, if we use the term fish properly, it just means all vertebrates, really. We often use the term fish for specific groups of vertebrates that stayed in the ocean, but including cartilaginous fish like sharks and rays, and bony fish like our coelacanth here, and a goldfish, right? So the funny thing is about using that archaic classification system is that that if we go by the law of monophyly and use that term fish, then we are fish, and because we're actually closer related to that goldfish and the coelacanth than any of us are to sharks, right? Sharks are a completely different clade, but we still lump them in with fish because they have sort of these basal characteristics that of a species that never left the ocean, right? That's always lived in the water. That's always lived in an aquatic or marine environment. They have these basal characteristics. We're just fish that that thrived in an ecosystem that was the water had poor oxygen quality, so probably marshy, maybe brackish water. Where there was not a lot of oxygen that we could get out of the air with our gills. So we developed a lung system from our swim bladder to absorb oxygen, and we would swim up and take gulps of air out of the environment above. And so we started spending more time at the surface, more time closer to the shores and things like that. Moved into a niche where we were moving on to land. That's ancestor of all tetrapods. So we are just fish that thrived in brackish water and learned how to take oxygen. I say learned how to, but started taking oxygen from the environment above. That's how that happened. So we're fish, they're fish, we're all fish. Every vertebrate's fish. And the term itself is what you'd call polyphyletic, which is where you take a clade and you say a clade that includes all the representatives except for this group within it. I'm going to take this group that's nested right in the middle and pull it out. That's polyphyletic. And what you do with this is you're basically taking tetrapods out, taking tetrapods out of the fish group and separating them out. And that's where you get the term fish. And that's where fish is applied. And it's not very useful for scientifically classifying things. And that's what the obsession with coelacanth is, because fish are divided into bony fish are divided, and that includes us, are divided into two groups. There's I'm gonna use it's not really two groups, but just to give us some guideposts, we're gonna draw a loose circle. The ray fin fish and the lobe fin fish. And we are lobe fin fish, and so are coelacanths. There are other lobe fin fish around too, but for some reason the focus is on the coelacanth, which is okay. But obviously Tiktaalik is the poster child for these lobe fin fish that first moved into an aquatic environment. There was somebody on Standing for Truth's channel a few weeks ago that said that the Tiktaalik was an alligator skull, and I'd love to explore that. I would love to dive into that. So we are going to have to see if we can't get this gentleman maybe in here or someplace where he'll talk to me and explore that claim. Am I using big words? I'm sorry. Oh, no. No, Dr. Tapioca Weasel is. And he learned it from Titan. Damn it, Titan. Dr. Tapioca Weasel has had enough education. His head's going to explode if you keep trying to stuff things in there.
Somehow avoided being eaten into extinction by an ever-escalating biological arms race.
Okay, so there were no radiodontids at the time of the coelacanth. Radiodontids, that's our arthropod that the shark just munched on, were not around by the time that coelacanth showed up on the scene. Sharks were, though.
Race that supposedly furnished every other animal in the ocean with more evolved, elaborate, and highly advanced weapons of predatory warfare. As it turns out, and according to this paper published in 2018 and this one in
it's almost like they have a stable niche and didn't get those pressures in the environment they live in. Maybe the arms race has stabilized millions of years ago, much like it has on the arthropod microcosm, where you don't see new groups of insects just changing in vast and exciting ways at this point in time. They've been stable since the Triassic, right? And mammals have not been stable that long. Some insect clades have been stable in their environments since the Carboniferous. This is not news. Beetles, again, stable since the Carboniferous. Dragonfly, stable since the Carboniferous. It's okay to survive and thrive in a competitive environment if your body plan is sufficient. If you are adapted to and I say perfectly, it's survival of the fittest. If you fit in your environment the best, you don't get pushed out. That's what we're talking about with the coelacanth, the dragonfly, all these animals, sharks.
2021, coelacanths may have been more diverse than previously thought anyway, so we can also discard this hypothesis as well. More recently, researchers concluded that the similarity of form between Devonian coelacanths and the modern Latimeri was due to an extremely slow rate of genomic evolution. In other words, coelacanths just didn't evolve very much. Cassane and
Right, because they're stable in their environment, so there's no need for mutations to take hold in the population when there's no mutation process needed for the species to thrive. There's no if any radical mutation is going to result in less success and less successful reproduction, like albinism, for instance, in their environment wouldn't be successful because being white in a dark zone like that is might be detrimental. But then again, not a lot of things see down there, so maybe it doesn't provide detriment to the species and is able to take hold. There's going to be different factors like that come into play.
And Laurenti in 2013, however, point out the difficulties associated with such a hypothesis. Genomes change continuously under the combined effects of various mutational processes that produce new variants and genetic drift and selection that eliminates or fixes them in populations.
Yeah, and if the changes are not beneficial and successful, then they don't take hold. There's because there's a low rate of successful mutations among a group, just shows that the group is current physiology of the organism is more efficiently adapted to the environment than any of the mutations that have taken hold so far.
In other terms, the only possibility for genomes to replicate without change implies at least one of the two following conditions. 1. New variants do not appear, i.e. no mutations, and 2. New variants are systematically eliminated by selection. In other words, how can a genome remain virtually unaffected by mutations for a period of over 4?
Because all the mutations were unsuccessful. I don't understand why that's hard to wrap your head around either. The unsuccessful mutations don't reproduce in the environment. So thus far, any mutations that have deviated from this basic body plan for this organism within this biome have not shown to be more successful than the stable population's current genetics. So they're removed from the population. It's not complicated. This is Not even, you don't even have to get into the genes to see this. We can see this with selective breeding in domestic organisms.
400 million years. Notice that in each one of these solutions, the scientists are appealing to mechanisms that somehow slowed down the rate of evolution by huge orders of magnitude. And it's important for creationists to detect the problem here. And it's not evolution. The fact is that natural selection, well, it's a scientific surety, and vast amounts of diversity have certainly occurred since the flood of Noah. In fact, even in the secular realm, more and more scientific research is showing that species are diversifying at astonishingly rapid rates. Living fossils, therefore, do not necessarily challenge evolutionary assumptions. If the Devonian Diplocetes went extinct 100,000 years ago, we wouldn't be having this conversation. And that's because there's enough wiggle room in the rates of evolutionary change to allow for stasis over shorter periods of time. Secular scientists, however, believe Diplocetes went extinct 400 million years ago, and for obvious reasons that presents a problem, and a huge one at that. There is simply no known mechanism that can adequately explain 400 million years of evolutionary stasis.
Why? What about sharks? Sharks are evolutionary stasis. What about beetles? Dragonflies? All these things that we've talked about in the show today. I want you to take note of those as he presents this argument. He's only using coelacanth because for most of historic time we thought it was extinct. That it was only known from the fossil record until in the 1940s we found one off the coast of Madagascar, and ever since we've been finding them in the deep waters around the world in this specific very stable zone of the ocean. His focus on this species is based strictly on that, the cryptozoological aspect of it. So that's why I love talking about it, because it's a silly argument. And they would not make this argument about beetles being stable in the environment. They wouldn't say, hey, but beetles though, how did beetles survive all this time in stasis in physiological stasis? Because coelacanths weren't always in just this niche, right? I don't want to present that mischaracterization. I think they've always been open water fish, but there were coelacanths that lived in the Devonian onward, and I believe up into it might have been the KT extinction, that lived in a variety of environments for a long time. So they did diversify from their origins. There were different coelacanths that lived in different biomes and competed with different for different niches, I should say, that may have lived higher in the water column, lower in the water column, may have lived even in shallow waters at certain points in history. Their ecology is not limited to what their ecology was not limited to what the limitations of their ecology is now, where they've managed to hold out. Same situation like we talked about with the tortoise. The group is isolated in a very specific kind of environment, separate from where it's been separated from environmental stressors and competition for millions of years. They do not change much. That's why, tortoises and things on these are giant on these islands and able to persevere despite being extinct in the rest of the world. Same thing with the coelacanth that survive today and their little isolated pockets in these in this very specific type of biome. There's I believe it's like there has to be certain qualities to the water and everything for the current species, and the pressure, even the water pressure level, has to be just right. They have to be maintained. Like when we pull them up, I don't think they survive the journey to the surface. I might be wrong about that, but I don't think a coelacanth can make it to the surface without dying, without depressurizing, if you will.
In very complex organisms. The issue then for the evolutionist is time and not the absence of evolutionary change, the typical refutation offered by creationists. The existence of not just one, but of over 600 living genera that supposedly have 70 to 500 million year old fossilized ancestors is, in my opinion, one of the most powerful indicators that those ancestors didn't actually live 70 to 500 million years ago, but lived just thousands of years ago instead. And this, I believe, is where creationists should be focusing their attention. And this brings us to...
But that's nonsense, right? They have, these are not the same species that they were then. Just because they filled their niche and are really good at it and haven't been able to be pushed out of it does not mean that they only existed thousands of years ago. They can hold organism can hold an ecological niche a lot longer than you seem to accept.
To the fourth and final solution. Well, perhaps coelacanths are not living fossils after all. Those who champion this view assume that since Darwinian evolution is true, and since 400 million years of time have actually passed, then coelacanths must have undergone a huge amount of evolution. This means that the present-day coelacanth cannot be closely related to the Devonian Diplocetes, or in fact to any ancient...
Why not? Why can't it be closely related? You're weird. You're making weird arguments, making weird claims. Why can't it be closely related just because it was millions of years ago, hundreds of millions of years ago, as long as the species is stabilized in its environment and undergoes little change. Again, these are not going to be the same species. There's no indication that Diplocetes was lived in the same niche, even as the modern coelacanth. There's no reason to assume that. But it's definitely closely related, being this Sarcopterygian group. Right? They're a whole family of fish.
Coelacanth. As such, we need to stop calling it a living...
Of jawed fish, I should specify.
Fossil, which of course leads us to my opening question at the beginning of the video. For a response to this recent claim, then please join me in part 2. So that's all from me, Ken Colson here at Creation Unfolding. Look, if you were in any way blessed by this video...
No, I was not. All right. So that was Creation Unfolding. There is a part 2 to this right here. I'm not going to do it this week. It's just about the same length. I might follow it. We can follow up with it next week if you all really want me to. Do this. Why I do my next transition. I want you to put a 1 in the side chat if you would like me to cover part 2 of this next week. And I want you, actually, you know what? I might just do a poll. Let's just do a poll. I closed my YouTube window as it was buffering. Let me pull it back up. There we go. I'll add a poll. And we'll do that instead. So, there you go. All right. So that was Creation Watch. Creation Unfolding, the Coelacanth, part 1. There may or may not be a part 2. I hope by the time that you watch this, if you're watching this on Creation Watch Wednesday. Yeah, how can you be blessed by a video? I get you, Mark. I don't get it either. Anyway, so, yeah, thank you for joining us on Creation Watch Wednesday. My beauties and bees, please remember to be kind and take care, and I will see you next time.